Did you know there's a design that's possible in software development but hard to do in a database? In this video, I'll explain what it is, why it's hard, and the different ways you can solve it, and my recommended solution. So, what is this design? It goes by a couple of names: polymorphic association, alternative parents, or multiple foreign keys. It's where a table can be related to only one of several different tables. Why is this hard? In relational databases, a foreign key relates to a primary key in another table. This can only relate to one table, not multiple. Here is an example. Let's say we're designing a database for a blog. A blog has posts, it has videos, and it has photos. A user can also leave comments. They can leave a comment on a blog post, a video, or a photo. But when we want to store a comment, we need to specify what kind of record the comment is for, whether it's a post, a video, or a photo. If it was only one table, we would add a foreign key. This diagram shows this object ID field in the comment table as a foreign key to all three tables. But we can't add a foreign key that refers to multiple tables and ensure that only one is entered. So how can we design our database to meet this requirement? There are several solutions to this. Let's take a look. The first option is called multiple foreign keys. You allow a comment on any of these object types by adding a separate foreign key for each table to the comment table. In this example, we've added a post ID to the comment table, which is a foreign key to the post.post ID. We've done the same for the video ID and the photo ID. 3 columns, 3 foreign keys. This is a valid use of foreign keys. However, there's nothing to stop someone from adding a value to more than one of these columns for a specific row in the comment table. We could insert a comment row that has a value for both the post ID and the video ID. But the requirement says that the comment can only belong to one object, not two. So we'll have data quality issues here. We could overcome this by writing a stored procedure to populate this table and ensure all applications go through the stored procedure. But this may not be ideal if your company or application doesn't want to use stored procedures. The second option is, instead of having separate tables for each of your record types, you have a single table that stores all of the record types. So instead of a separate table for post, photo, and video, we have a single table called content. It stores all of the columns needed for the different types of data. Some columns may be shared across types of content, and others are unique to a type of content. The comment table can then link to a single table's primary key, and we can see that here with the comment.contentID column. We also have a lookup table here, which indicates what type of content each record is. This is so we can tell whether the content record is a photo, post, or video, for example. This is a valid use of a foreign key. It can also be easier to work with. However, there will be columns in the content table that will be empty. Depending on the different types of content you have and how many fields exist for them, this could be a lot of columns. If you're interested in creating an effective database design from an idea and writing the SQL to create it in a database, you'll enjoy my Effective Database Design course. Check out the link in the description. The third option is called super and subclasses, or base and child classes. Here's how it works. You have separate tables for each type of record. In this example, we have post, video, and photo. They each have a primary key value, such as post ID for the post table. Then we have a table called content, which has a primary key called ID, and maybe some other fields. How are these related? The ID column in the content table is a primary key, and the foreign key is stored as each table's primary key. A column can be both a primary key and a foreign key. Finally, we have the comment table, which has a foreign key back to the content table. This ensures that a comment is related to only one record. The content table is the superclass or base class, and the other post, video, and photo tables are the subclasses or child classes. How does the data in the content table and the other tables work? Well, when you add a new post or photo or video, you will need to insert a row into the content table first, then get the ID that was just inserted, and use that as the ID for the related post, video, or photo table. The advantage of this approach is that it meets the requirements and it allows you to have separate tables to store only the related information. However, it's a bit more work to set this up and add data to. Also, depending on the data you need for each type, you'll need to use the base table and the child table to get the complete picture for a record. But the solution works. Option 4 is where you have separate tables for each type of object that you need to relate data to. In our example, we keep our 3 tables for posts, videos, and photos. For our comments, we have 3 separate comment tables, one for posts, one for videos, and one for photos. They each have their own IDs, the foreign keys to the matching table, and most likely the same columns in each table. The advantage is that it enforces referential integrity, like the others, meaning that the foreign keys work. It may also be simple to work with. However, it means you'll have the same kind of record separated over multiple tables. If you want to get a complete picture of all comments, you'll have to get data from multiple places. This may or may not be an issue for you. Any changes to the concept of a comment will need to be made in all of the comment tables, so you'll need to take extra care to make all of the changes. The 5th option is where you don't have any foreign keys at all between the comment table and the different content tables. However, you store the ID of the related record in the comment.contentID field. You also have a content type ID field, which comes from the lookup table and could be either a post, video, or photo. This means that the content ID value in the comment table is related to one of these other tables, but there's no foreign key to indicate it. We can tell which type of record it relates to by the content type ID field. This solution will keep to the original structure of a single comment table and separate tables for each type of object. However, this is a pretty poor design as it doesn't enforce referential integrity between the comment table and the other tables. This can lead to poor data quality. You would need to have some pretty robust logic in the application or stored procedures to make this work, but it's still risky. I've only added this here as a possibility and to explain the pros and cons. I don't think it's the best design. So which option is best? What you want to do depends on your situation. How many different types of tables do you have? How different are they? This will determine how many columns are needed in each of the tables and how many tables are needed. My recommendation, however, would be option 4, which is having a separate table for each type of record you want to relate to each type of object. It's a clean solution, it enforces referential integrity, and it doesn't require the kind of extra logic that some of the other solutions do. Adding extra tables may seem wasteful, so you may not prefer this design, but this would be the one I would go for in most situations. My second choice would be option 3, super and subclasses. What do you think? Which option do you prefer to use? Are there any that I've missed? Let me know in the comments. Thanks for watching.